Hello everybody, welcome into another lesson. So today we are going to start the unit on systems of equations. So I know we've done some systems of equations since Algebra 1 and even a little bit in geometry we did some. Well, we're going to start out the first couple lessons. The first few we'll do systems of equations in 2 variables. Then we'll even do some in 3 variables. We'll get into the 3D graphing system a little bit later in this unit. But today we're going to talk about solving systems of equations graphically. The idea of this is to show you what's going on graphically when we solve a system of equations. And of course, solving a system of equations is figuring out the intersection of 2 lines. So here we have this system. We have the first line, 2x plus y equals 13. We have the second line, 5x minus 2y equals 1. The idea of solving this system is figuring out where these 2 lines intersect. Of course, there are algebraic methods such as substitution and elimination, which we will talk about in the next lesson, but I think it's important to show you graphically what's going on. So let's take the first line, 2x plus y equals 13. Let's graph that. So if we want to find the x-intercept, set y equal to 0, you would get 2x equals 13. Well, that would give you x equals 13 halves, which would be at 6.5. 2, 3, 4, 5, 6. So right about here would be 6.5. Then find the y-intercept, set x equal to 0. That would give you y is 13. 6, 7, 8, 9, 10, 11, 12, 13. Alright, so we found that. We found the x and y intercepts. Let's go ahead and draw the line. I am not good at drawing at angles. Not at all. Hang on a minute. Alright. And then we're going to graph 5x minus 2y equals 1. So find your x-intercept, set y equal to 0, 5x equals 1. That would give you 1/5 for the x-intercept, which would be about right there. And then find your y-intercept, set x equal to 0, negative 2y equals 1. So y would equal about negative 1/2. So we've plotted our x and y intercepts. Now let's draw the line through those points. And we have the 2 lines, and you can clearly see they intersect. I think it helps to label your intercepts also. So x-intercept would be at 13 halves 0. Y-intercept can be found at 0, 13. Then let's see, on this graph here, you have your x-intercept can be found at 1/5, 0. And then you have your y-intercept can be found at 0, negative 1/2. So label your intercepts. Now, here's the problem with solving graphically. The best way, if you're going to take the graphing approach to solving a system of equations, is to use a graphing calculator. That'll give you an accurate result every time. One second here. Alright, but anyway, if you're trying to draw a graph freehand and solve, you're going to end up having to estimate. The problem is with solving graphically, it's largely estimation if you're not using a graphing calculator. The best way, if you're not going to use a graphing calculator, is either to get a ruler and draw the lines as evenly as you can, like I try to do, and even then that's not a guarantee. You're going to be estimating. Or use graphing paper, which honestly, who uses graphing paper in 2026? I'm sure some do, but very few. But we're going to try to estimate where these two lines intersect. So let's see, it looks to be 1, 2, 3, 4, 2, 3, 4, 5. It looks like these lines come together at the point 4, 5. So the solution to this system of equations would be at 4, 5. It looks like the two lines intersect roughly at the point 4, 5. So again, graphically, you're largely doing estimation. We'll only do a few of these examples here. Just trying to not destroy this axis completely since I drew it semi-even. That's all. That'll be about as even-steven as I can get that. Alright, that should do it. Anyway, so what is the next system of equations? So let's say we take x plus 2y equals 9. Then we have negative x plus 6y equals negative 1. Alright, so you have this system here, x plus 2y equals 9, negative x plus 6y equals negative 1. Well, we'll plot the first line in red ink, x plus 2y equals 9. So find your x-intercept, set y equal to 0, you would get x equals 9. So find 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There is your x-intercept. Now, set x equal to 0, that would give you 2y equals 9, which would give you y equals 9 halves, which would put you at 4.5. Now we're just going to draw the line through those 2 points. So there is x plus 2y equals 9. Now let me get the blue ink for negative x plus 6y equals negative 1. Well, find your x-intercept, set y equal to 0. You would get negative x equals negative 1, which means x equals 1. So here's 1, 0 for your x-intercept. Now, find your y-intercept, set x equal to 0. You would get 6y equals negative 1. Y would be negative 1/6, which is about right there. So plot the line through those points. And then let's go ahead and label all of our intercepts here. So 9, 0 for the x-intercept. 0, 9 halves for the y-intercept on the red line. Let's label the blue line. So you'll end up having, of course, 1, 0 for your x-intercept. You'll end up having 0, negative 1/6 for the y-intercept. So we've labeled all our intercepts on the lines. Now let's find the point where the lines intersect. Again, this will probably be about an estimation. It looks to be at 4.5 in the x direction and about I would say 2 2/3. So it almost looks to be nine halves, which would be 4.5. What's 2 2/3? That'd be 8/3. It looks to be roughly that your point of intersection of the two lines would be at 9 halves, 8/3. Now, again, since we're only doing it graphically, this may not be exact. The only exact way to get these, besides doing it algebraically, is going to be if you put this into a graphing calculator and have it solve the system for you. That'll give you an exact answer. And I don't really do anything with graphing calculators in this course because that's a little too hard to try to get on screen and stuff. But that's where you'll definitely want to consult your teacher for that, or YouTube or something, for how to operate the graphing calculators. That would almost require its own course just for that, and I'm here more to teach the math than I am about technology. Not that the technology isn't useful, but I could show you by hand how to do stuff, but when it comes to the graphing calculators, that's best left to having its own teachers. Alright. There you go. Let's do one more. 3x minus y equals 12. Negative x plus 8y equals negative 4. Alright, so there's this system of equations. We're going to graphically solve that. So let's get our red ink for 3x minus y equals 12. Find your x-intercept, which means y is 0, so 3x equals 12, that would give you x equals 4. So 4, 0 is your x-intercept. Now, to find your y-intercept, that means x is 0, negative y equals 12, so y would equal negative 12. 3, 4, 5, 6, 7, 8, 10, 11, 12. Alright, so let's go ahead and draw that line. Let's draw a line. Okay, so there's my line, 3x minus y equals 12. Now let's figure out negative x plus 8y equals negative 4. So to find the x-intercept, y is 0 then. Negative x equals negative 4, so x would equal 4. Well, what do you know? That's also my x-intercept on the other line. And then y, find the y-intercept, x equals 0, so 8y equals negative 4, so y would have to equal negative 1/2. So let's do that and draw the line through those points. Alright, so we have our two lines graphed. Well, we have the x-intercept on both of them being 4, 0. Then we have 0, negative 1/2 for the y-intercept on the blue line. And on the red line, we have the y-intercept being 0, negative 12. But what do you notice? I think it's very plain to see these two lines intersect at 4, 0. They both intersect at their x-intercepts. So that's easy. These two lines intersect intersect at 4, 0. So that's how you do it graphically and get a rough estimate. And sometimes it's painfully obvious, like it was with this graph, where they intersect. But that's not always the case. Now we're going to do a few exercises here. So let's see. Check whether the ordered pair is a solution to the system of equations. All right, so we're going to be given an ordered pair and a system of equations. It's going to be our job to determine, is that ordered pair the solution? We have the ordered pair 6, -1. The system is 4x minus y equals 25. Then we have -3x minus 2y equals -16. So if you have a system of equations and they give you a potential solution with an ordered pair, what you're going to do to check and see if it's a solution is put this ordered pair into both of the equations. So let's start with 4x minus y equals 25. If you put the x and y values in to this equation, you should get 25 on the left-hand side, which would give you a true statement of the left side equaling the right side. So if I take 4 times my x value of 6 minus my y value of -1, set it equal to 25. Well, 24 minus 1 is 24 plus 1 equaling 25. 25 equals 25. It checks out. So yes, 6, -1 is a solution at least to this line. Is it a solution to the other line? Take -3 times your x value of 6 minus 2 times your y value of -1. Set that equal to -16. -3 times 6 is -18. -2 times -1 is +2. Set that equal to -16. And then -16 equals -16. So yes, it's a solution to both lines. So yes, this is a solution. This ordered pair is probably the solution to this system of equations. It checks out in both equations when you stick the x and y values into the equations. If it wasn't a value for even one of them, then it's not a solution. It has to be a value for both of them that check out. All right, what's next? Is the point 30 a solution to -x plus 2y equals 3, and then we have 10x plus y equals 30. Make sure I got that right. Okay. Alright, so is the point 30 a solution to this system of equations? Well, let's find out. Put in your x value of 3 at x, you would actually get -3 plus 2 times your y value of 0. Set that equal to 3. Well, you would just get -3 equals 3. Well, -3 does not equal 3. We can stop right there. We have a false statement. So no, this is not a solution to this system. Interestingly enough, though, if you put in 3, 0 for the second equation, it would be a solution. But it has to be true in both equations in order for it to be a solution. That's how you're going to test it. All right. How about the point -2, -8? Is that a solution to the system of equations 2x minus y equals 52, and then 9x minus y equals -10? So here's your system of equations, and you're given the point -2, -8. Is that going to be a solution? Well, let's plug in the x and y values into 2x minus y equals 52. So take 2 times -2 minus -8, set that equal to 52. Well, 2 times -2 is -4. -8, well, that's plus 8. Set that equal to 52. That would give you 4 equaling 52, which is a false statement. So right away, no, this would not be a solution to the system of equations since you get a false statement. Now, if you put this into the second equation, it would be a solution, but it has to be a solution to both, not just one of them. All right. Let's do 2 more. This time we have the point 1, -1. We got -3x plus y equals -4. Then we have 7x plus 2y would equal -5. All right, so is this point a solution to the system of equations? Let's put it into each equation. So start with -3x plus y equals -4. So put in +1 for x, you'll get -3 times 1 plus your y value of -1, set that equal to -4. -3 times 1 is -3, then you have -1 equal to -4. Well, -4 equals -4. So far it checks out for the first equation, but we still have to consider the second equation. If I take 7 times the x value of 1 plus 2 times the x value of -1, set that equal to -5, well, I would get 7 minus 2 equal to -5. That would have me saying 5 equals -5. Well, +5 does not equal -5. So no, since it doesn't work for the second equation, this point is not a solution to the system of equations. It has to be present in both in order for it to be the solution. We'll do one more. What if we're given the point 0, 2, we have the system 17x plus 8y equals 16. Then we have -x minus 4y equals 8. So is the point 0, 2 a solution to this system of equations? Well, let's stick it into the first equation. Take 17 times your x value of 0 plus 8 times your y value of 2, set that equal to 16. 17 times 0 is 0, but 8 times 2 is 16. 16 equals 16. It checks out for the first equation, but does it check out for the second equation? Take your x value of 0, you'd have negative of 0 minus 4 times your y value of 2, set that equal to positive 8. Negative 0 is just 0. Negative 4 times 2, that's negative 8. Set that equal to 8. Well, negative 8 does not equal positive 8. Not at all. So no, this is not a solution. This is not a solution to the system of equations since it doesn't work in both equations. I'm going to do one more. There's one more I just got my eye on. Then that's it for sure. How about we get to a yes? We've had a lot of no's lately. What if we get the point negative 3, negative 5 for the system negative x minus y equals 8, and then 2x plus 5y equals negative 31. Is this point a solution to the system of equations? Well, let's start sticking the x and y values in. Negative x minus y equals 8. Take your x value, so you'll have negative of negative 3 minus negative 5 for your y value. Set that equal to 8. Well, negative 3 is positive 3. Minus 5, that's plus 5. Set that equal to 8. 3 plus 5 equals 8. And 8 equals 8. That's a true statement. It checks out for the first equation, but what about the second one? So take 2 times your x value of negative 3 plus 5 times your y value of negative 5. Set that equal to negative 31. 2 times negative 3 is negative 6. 5 times negative 5, that's negative 25. So you have negative 6 minus 25 equal to negative 31. Well, negative 6 minus 25 is negative 31. And negative 31 definitely equals negative 31. This point checks out for both equations, so yes, this is a solution to the system of equations. So, since it checks out for both equations, yes, this is a solution. So that's it for solving systems of equations graphically. Next lesson, we're going to talk about algebraic methods of solving systems of equations, such as substitution and elimination. So I hope everyone has a great day. Take care.